In this video, we will be covering part 1.2 of chapter 1 chemical reactions and equations. We will learn different types of chemical reactions and also corrosion and rancidity concepts. Different type of chemical reactions that are in our syllabus include combination reaction, decomposition reaction, displacement and double displacement reactions, as well as redox or reduction oxidation reactions. Let us take a look at the first type of reaction, which is a combination reaction. This is also called a synthesis reaction. This reaction occurs when two or more simple substances combine to form a simple or a complex product. Here we can see how this equation looks like. A plus B together will form AB. That means they're combining. That's why we call this a combination reaction. An example of this is formation of water. Hydrogen gas reacts with oxygen to form water, and the chemical reaction is written as 2H2 plus O2 gives 2H2O. Here in the image on the right side, we can see two hydrogen molecules are reacting with one oxygen molecule in order to form a water molecule. Another example is formation of calcium oxide. Calcium and oxygen react together in order to form calcium oxide, which we also call as quicklime. The second type of reaction is a decomposition reaction. A decomposition reaction involves a single compound breaking down into two or more compounds. This is an example that is exactly opposite to the combination reaction that we just learned. Over there, A plus B became AB. Here, AB will become A plus B. One example is decomposition of water. When we do electrolysis of water, as shown in the figure here, water breaks down into hydrogen and oxygen gases, and we write this reaction as 2H2O gives 2H2 plus O2, that is hydrogen and oxygen gas. Another example is the decomposition of calcium carbonate. When we heat limestone, it decomposes into calcium oxide and carbon dioxide as given by the equation here. The third type of reaction is the displacement reaction. We also call this as a single displacement reaction. In a displacement reaction, one element replaces another element in a compound. An example can be seen here where we write this as A plus BC gives AC plus B. In order to understand which element replaces another, we can take a look at the reactivity series that we can see here. As we can see, the elements are listed from highly reactive to non-reactive elements. In a compound, when we react these elements together, a highly reactive element replaces the non-reactive or less reactive element. Let's take a look at an example here. Iron displacing copper. When iron is placed in a copper sulfate solution, it displaces copper to form iron sulfate and copper. Why does this happen? If you can see the reactivity series on the right side, we can see that iron is on top compared to copper, which is at bottom. So iron is more reactive and it will replace copper. Another example is zinc displacing hydrogen. When zinc reacts with hydrochloric acid, it displaces hydrogen to form zinc chloride and hydrogen gas. Again, here on the reactivity series, we can see that zinc is higher than hydrogen. So, zinc is going to displace hydrogen. What is a double displacement reaction? In this, two compounds exchange their ions to form two new compounds. Here, AB plus CD will become AD plus CB. Let's take a look at an example of sodium chloride and silver nitrate. Here, sodium chloride plus silver nitrate gives us silver chloride and sodium nitrate. An example can be seen on the image on the side where you can see the silver and chloride atoms together are forming a precipitate at the bottom of the beaker. This is an example of double displacement reaction. Another example is between barium chloride and sulfuric acid. Here, barium sulfate and hydrochloric acid are formed. The last type of chemical reaction is a redox reaction. This involves an oxidation and a reduction reaction. Let's understand what's an oxidation reaction. Here, oxidation occurs when a substance gains oxygen. For example, in the combustion of magnesium, magnesium gains oxygen and becomes magnesium oxide. So here, this is an oxidation reaction. In a reduction reaction, a substance loses oxygen. For example, when you extract iron from iron oxide in a blast furnace, Fe2O3 becomes Fe, that is iron oxide becomes iron. Here it's losing oxygen. So we call this as a reduction reaction. Now a redox reaction is nothing but when this oxidation and reduction occur together. In this reaction between copper oxide and hydrogen, CuO plus H2 becomes Cu plus H2O. Here we can see that copper oxide is losing oxygen and oxidation is occurring, and hydrogen is getting oxygen and becoming water and reduction reaction is happening. So a reaction in which both oxidation and reduction are occurring is called a redox reaction. What is corrosion? Corrosion happens when a metal reacts with oxygen and moisture over time. The effect of corrosion is that this metal will become weaker, flaky and lose its strength. The common example is rusting of iron. When iron is exposed to air and moisture, it is going to form iron oxide, which is a brown color thing that we see as rust. Here on the image we can clearly see that an iron link has gathered rust on it, which is brown in color. A chemical equation for this can be written as iron plus oxygen plus water gives us iron oxide. Now, in order to prevent rusting, because it's going to reduce the usefulness of the metal, we can do painting or coating, and also there's a chemical method called galvanization which protects it from oxygen and moisture. What is rancidity? Exposure of fats and oils to oxygen, light or moisture causes food items usually to go rancid, and now this food develops an unpleasant odor or taste. Common example is spoiling of butter. Butter is an oil. When you leave it in open, it starts melting and breaking down of oils and fats happens and it turns rancid, as we can see an example of rancid food on the image given on the right side here. In order to prevent this rancidity, we usually use refrigeration. That is, we put the food items in the fridge in order to avoid rancidity or slow it down. Another method is to add antioxidants such as vitamin E, which also prevent rancidity. With this, we have come to an end of chapter 1.